Ladies and gentlemen, today I'll be presenting on mathematics. On mathematics today I'll be talking about one of the branches of mathematics called calculus. What type of calculus is this? This type of calculus is called differential calculus. Why differential calculus? Because it deals with the rate of change. However, ladies and gentlemen, we'll be finding the equation of the tangent line using limit, derivatives, definition in order to solve our problem. On this note, we want to find the equation of the tangent line given that f of x is equal to x squared plus 1, having the points parenthesis open 2, 5 it closes, using m tangent equal limit as h approaches 0, bracket open, f parenthesis open, x plus h it closes minus f of x, bracket closes over h. Calculus was introduced or developed by Sir Isaac Newton and Gottfried Leibniz. They developed differential calculus in the 17th century. It was between 1665 to 1680. Based on this information, ladies and gentlemen, we'll be looking at our mathematical formula in order to solve our problem. However, ladies and gentlemen, to solve our mathematical problem, we say solution. On our solutions, we say let f of x will just be equal to x squared plus 1. And at x will just be equal to f plus h. In conclusion, we say f parenthesis open x plus h closest should be equal to parenthesis open x plus h equals all square plus 1. So based on this information given, ladies and gentlemen, we'll be using it in our mathematical formula to solve our problem. Taking our mathematical formula, we say m tangent will be equal to lim or limit as h approaches 0. What happened here? Bracket open, f parenthesis open, x plus h closing minus f of x bracket closes over h. We'll be using this mathematical formula, ladies and gentlemen, to solve our problem. We already have our information here, so we'll be taking this information to place here in order to solve our mathematical problem. Remember, we have the value for this guy, and we also have the value for this guy. And the value for f parenthesis open x plus h it closes is this. And the value for f of x is just equal to x squared plus 1. So this is the value for f of x, and this is the value automatically for f parenthesis open x plus h. So what we see here, we take the values and place them there to solve our problem. So we say m tangent will be equal to limit as h approaches 0. What happened here? Bracket open. So we have this guy, we take the value for that guy and place it there, and the value becomes parenthesis open x plus h it closes all square plus 1. So we say parenthesis open x plus h it closes all square plus 1 will be used to represent this guy. And what we have here, minus, and f of x will just be equal to what we have, x squared plus 1. So we take this guy and place the guy here to represent this guy, which is f of x. So f of x now will be equal to, we have parenthesis open x squared plus 1, put in parenthesis, bracket closes over h. On this note, we'll be using this guy to solve our problem. What do? We say M tangent now. M tangent will be equal to limit as h approaches 0, bracket open. We expand this guy. We say parenthesis open, we have x plus h. In expanding this guy, another one will be x plus h. So close it. What we have here? Plus 1. What we have here? Minus. And this guy will be parenthesis open. X squared plus 1. We close this. What we have? Over h. So ladies and gentlemen, we'll be looking at this to solve our mathematical problem. Remember, we are solving this mathematical problem on a differential calculus. And differential calculus was introduced by Sir Isaac Newton and Godfrey Leibniz, and were later formalized by one of the greatest mathematicians today called Augustin Louis Cauchy, specifically in 1821. He also made a contribution to limit. So on this note, ladies and gentlemen, we say M tangent will be equal to limit as h approaches 0. What we have here, we say bracket open. We will multiply the values in the first parenthesis or the values in the second parenthesis. In so doing, we say x times x, we have our x squared plus x times h, we have sh plus h times x, we also have xh plus h times h automatically will be equal to a squared. What we have here? Plus 1 minus, and we take this guy, which is s squared plus 1 bracket closes over h. So ladies and gentlemen, we'll be using this in order to solve our mathematical problem. So on this note, we see M tangent now will be equal to limit as h approaches 0. What do we do? Collect like terms. We say bracket open in order to collect our like term. Remember, the x squared plus 1 will be coming to x squared plus 1, and xh plus sh plus h squared will be coming together in order to solve our problem. So when we combine this, we say xh plus xh will give us 2xh plus what we have here is h squared. What do? We say plus. We bring this guy. We have s squared plus 1 minus s squared plus 1 bracket closes over h. Why we did this? We did it because we want this and this to be cancelled. Because s squared plus 1 minus s squared plus 1 is equal to 0. Automatically we cancel it. In how much, ladies and gentlemen, we use the guy to solve our problem. So we see M tangent now will be equal to limit as h approaches 0. So what do? We say bracket open, we take this guy 2sh plus h squared bracket closes over h. So we remove this guy from the bracket in order to factor this particular guy. So we see in our mesh, so we say, ladies and gentlemen, we say M tangent will just be equal to limit as h approaches 0. So what we have here? We have 2xh plus a squared over h. So we remove it from the bracket in order to factor this guy. So we say 2xh plus a squared over h. So what do? We factor this guy. So in factoring this guy, we say M tangent will just be equal to limit as h approaches 0. So in factoring the guy, we bring one h outside, parenthesis open, we get 2x plus h encloses over h. Because when we multiply h times 2x, we automatically give 2xh plus h times h automatically will give h squared. So on this note, ladies and gentlemen, we say m tangent will just be equal to limit as h approaches 0. What do? We found out this out because we wanted this and this to be cancelled. So here how much we take the guy now? 2x plus h. Remember, we already have the value for h, and the h value is equal to 0. So this guy will be representing this h. So we take the number for h, and the number for h is equal to 0, and place it there to solve our mathematical problem. So ladies and gentlemen, remember, this is differential calculus that was introduced by Sir Isaac Newton and Gottfried Leibniz. However, ladies and gentlemen, we have m tangent will just be equal to. Now we already have the value for h, and the value for h is 0. So we take this guy and place our value there. So we say 2x plus 0. Why 0? Because h automatically is equal to 0. So we say m tangent will be equal to 2x plus 0 is just 2x. But remember, we have a number or a value for x. What is the number or the value for x? The number or the value for x, according to our point here, is 2. So we'll be taking the point in order to solve our problem. So we say our point here is parenthesis open 2,5, and remember the 2 will be representing the value for x. So we say at x will just be equal to 2, and we'll have our point here 2,5. On our point 2,5, we have this guy to be x, and this guy to be y, in order to solve our problem. So remember, anywhere we see x automatically, it will be represented by 2. So we say m tangent now will just be equal to 2x, and m tangent will be equal to 2 times x. What is the value for x? Is 2. So m tangent will be equal to 2 times 2 will give 4. Automatically, the guy become the slope, which is expressed as what? As m. So we say 2 times 2 is equal to 4, and then 4 automatically become the slope. And we'll be using the slope on the equations of the tangent line to find our answers. So in our mesh, we say in finding our equations of the tangent line, we'll be using our mathematical formula. We say find the equation of the tangent. Finding the equations of the tangent line. Remember, we have our mathematical formula to be used. What is our formula? Our formula, in order to find our equations for our tangent line, y minus y1 will be equal to m parenthesis open x minus x1 encloses. To find the equations of the tangent line using this mathematical formula. Remember, we have our points. What is our point? Our point is parenthesis open 2, 5 encloses. But remember, based on the formula here, we have x and y. So this number, which is 2, automatically is equal to x. Y5 is y. So we express it as x1, y1, based on the formula. So when I see y1, I will take the number for y1, and the number for y1 is 5. And I also have the number for x1. X1 number is 2. Remember, we have the number for the slope, which is m, and our number for slope, which is m, automatically is equal to 4. So we take the 4 and place the 4 here to represent our slope, which is automatically equal to m. So ladies and gentlemen, on this note, we say y minus y1. y1 is 5. Remember, will be equal to m, which is the slope, and it's equal to 4. Parenthesis open x minus x1. What is x1 number? X1 number automatically is just equal to 2. So we'll be using this automatically to solve our problem. So what we have, y minus 5 will be equal to, we'll multiply the 4 by the values in the parenthesis. So we say 4 times x will give us 4x. What we have here, minus 4 times 2 automatically will give us 8. What do? We say this guy will go across here. This guy is negative. When you go across, automatically he become positive. So we see y will just be equal to 4x minus 8. What do we do? Plus 5. This guy have transfer automatically to the guy and he become positive. So what do? We say y will be equal to 4x. We get minus 8 plus 5. We will subtract 5 from 8, but the greater number will carry the sign. So what do? We take 5 from 8, we get 3, but the greater number here is minus 8. So that means that we will have negative. So when we take 5 from 8, automatically we get 3. Ladies and gentlemen, this is our answer for the equation of the tangent line. Y will be equal to 4x minus 3. Remember, this is on a differential calculus. And on a differential calculus, we're told that both Sir Isaac Newton and Godfrey Livingston introduced the differential calculus and were later formalized by one of the greatest mathematicians today called Augustin Louis Cauchy, more especially in 1821. So this is our answer for today. Ladies and gentlemen, thanks for joining me on this math journey. Keep practicing, keep pushing limits, stay curious, and learn across those derivatives. Always remember that mathematics is the key. Don't forget to like, share, stay tuned, and comment in the comment section. Once again, I'm B-Boy myself Jr., popularly or commonly known as Chachi, the all-time record breaker. Thank you.